Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This is Professor Ashil Zaman Khan from Government Muslim Science College, Hyderabad. We have today's topic is derivative of quotients of functions and quotient rule. So if we have the two functions, that is f of x and g of x, and they are dividing each other, f of x is divided by g of x. So how could we find out the derivative of those functions? So this is the statement of the function is that is derivative of f of x divided by g of x will be equal to g of x will be the same f dash of x and minus g dash f of x will be the same g dash of x divided by g of x whole square. So we are going to prove this by using first principle formula. As we have learned earlier that the first principle formula is that f dash of a is equal to limit x approaches to a f of x minus f of a divided by x minus a. So we are just going to solve it by using first principle formula, and what we are doing over here. So let f of x is equal to f of x divided by g of x, that is f over g of x, and g of a is equal to f of a divided by g of a, and simply that is f over g of a. So we are just going to plug in, instead of f of x we are plugging in f over g of x, and instead of g of a we are putting over here f over g of a. Just by plugging in that derivative of f over g or f over g dash is the same thing, that is limit x approaches to a f over g of x minus f over g of a divided by x minus a. After that, f of x divided by g of x dash means limit x approaches to a f over g of x means f of x divided by g of x minus f of x of f of a divided by g of a divided by whole divided by x minus a. So what will happen in the next step? Let's see. Now f over g dash of a will be equal to limit x approaches to a f of x, and we have getting LCM over here. So f of x into g of a, the g of x will cancel out g of x, and that is g of a multiplied by f of x, and again g of a will cancel out this g of a, and g of x will multiply by f of a. So g of x minus f of a whole divided by g of x into g of a divided by x minus a. So add and subtract, simple. This is LCM, and there is nothing special over here. We are just doing over here LCM. So again add and subtract f of a g of a in the numerator. In this numerator we have to add f of a into g of a. So f over g dash of a is equal to limit x approaches to a f of x into g of a minus g of x into f of a will be the same which is in the last numerator of the fraction, but we have added over here f of a into g of a minus f of a into g of a. Add and subtract f of a and g of a. G of x into g of a will be the denominator, and x minus a will be multiplied by x minus a. Now after that, what can we do? That we just these are the four values, and we have to pair up, distribute in two pairs, four values. So how can we do this? We are just separating first value and the fourth value. So f of x into g of a minus f of a into g of a, and the middle two values, by taking minus sign common, g of x f of a will be positive because we have taken minus sign common, and f of a g of a is positive over here, it will be negative because we have taken over here minus sign common. So f of a g of a. So we have separated, we have made two pairs of four values. So g of x into g of a x minus a will be the numerator. What will happen in the next? F over g dash of a limit x approaches to a. If we see this, this is really interesting. That is, we have over here g of a is common as So we have taken out as common. So f of x minus f of a will be remain in the bracket. In the same sense, we are over here, f of a is common over here. So we have taken out f of a common. So g of x minus g of a will be in the bracket. So g of x into g of a, x minus a will be the denominator. So what we can do over here, just splitting the limits and LCM on right hand side. We have to do this. So what will happen in the next step? Let's see. Now by splitting the LCM, f over g dash of a, and by taking out g of a is common, limit x approaches to a, f of x minus f of a divided by x minus a, and minus f of a is common throughout. So limit x approaches to a, g of x minus g of a divided by x minus a over here. So this reminds you a formula again, first principle formula of f of x, f of a and g of a, f dash of a and g of a dash of a over here. So again, limit x approaches to a, this is f of x minus f of a divided by x minus a is f dash of a, and limit x approaches to a, g of x minus g of a divided by x minus a is g dash of a. Just replacing these values in above equation over here. So instead of this, we are putting over here f dash of a, and instead of this we are putting over here g dash of a. By applying limits, what will happen? So by applying limit, f over g dash of a is equal to g of a is the same, the derivative of f of a, that is f dash of a, minus f of a is the same, the derivative of g of a, so g dash of a, that is g of a into g of a. Instead of x we are putting over here a, so g of a into g of a becomes g of a whole square. So what will happen? So over here, f over g dash of a will be g of a into f dash of a minus f of a into g dash of a divided by g of a whole square. This has become the derivative of a function at a specific point a. Or we have, if we put a instead of a, we are putting over here x, so f over g dash of x will be g of x is the same f dash of x minus f of x is the same g dash of x divided by g of x whole square. We can write this formula into two or three other forms. Let's see in the next step. So we have this formula u, if we put u is equal to f of x and v is equal to g of x, so u over v dash is equal to v same, the derivative of u with respect to x, minus u same, the derivative of v with respect to x, divided by v square. Or we can simply write u over v whole dash is equal to v same u dash minus u same v dash is equal to divided by v square. So this completes our the derivation or derivative of the quotient formula. So we will use it rapidly in the fraction form, the function which are given to the fraction form, so in the exercise. So this completes our today's lecture, and we will meet in the next lecture. Till then, Allah Hafiz.